Welcome back everyone. Now we are going to see that what are the segment registers. So let me mark it first so that you can see what are the segment register. Well, I'm talking about this place. So this is the segment register actually till this point actually. So this is our segment register. Okay, that's it for the work of my highlighter. Okay. So, what a segment register is actually. BIU has four segment registers, as I already told you. Like here we have CS, SS, DS, and ES. These are our segment registers. And through the segment registers, we actually start working on the processor part of the BIU. They are segment register. They have the addresses, as they are the register, they have the addresses of the data in the memory. Well, let me explain that in a fresh new page. Okay, so what we just said is CS, SS, and then we are having, okay, let's see, DS and ES. Okay. DS and ES. I'm not including IP, that's a different thing. We are going to discuss that just in a while. Okay, so these are the segment addresses. Segment address, ADDRESS. So they store the location where the memory is. Like here is our RAM or ROM or storage or whatever you like to call it. Well, I'm calling it RAM. Just the storage. We are focusing on the word storage and not the differentiation of those all the things. Yes, they do matter, but we have already gone through that all the things. For us, it's just the storage. So data is here. So let's say our data, which is A, for example, is sitting here. Here it's B, here it's D, here it's C. Yes, I put it very randomly because in reality, it's all the random data if we even able or try to see that. So what our segment registers have? Our segment register have codes, like a processor is demanding that I want the A. So segment address register, actually we will talk about these words in just a bit. So segment address register actually have the opcode of the required data. Like let's say the opcode or the address for the A is 0100. So it knows that it can have the A from this source. So it will go all the way to the memory and search that, do you have this, do you have this? Yes, I got here. And then yes, it will get fetched and then comes to the segment register. So segment address register, or you can simply say segment register. So let me explain that in a brief too, so that we can revise what we have just learned. BIU, well, let me also present the diagram and let me remove these things that I have drawn here. Okay, over extra creativity that we have made here. Okay, okay, almost better, almost perfect, I think it is. Yeah, so these are the things that we have talked about. So what are they? Segment register. Do they have the data? No, they have the location where the data is present, as we have seen here. And what else? It holds the address of instructions and data in memory. Well, we have discussed it the third time, I know, which are used by the processor to access the memory location. Well, that I already told you, obviously. It also contains one pointer register. Now something new came into the picture that I wanted to tell you, that here is the instruction pointer. The full form of the IP is instruction pointer. Instruction pointer. Well, just to satisfy the curiosity for a moment, this is the offset address. Well, we are going to discuss that one too, so don't worry about that. Now you might be wondering that I have not told you what is CS, SS, DS and ES. And I am telling you that IP means instruction pointer. Well, that only signify one thing, which is I'm going to tell you that right now. So, what is CS? Let's explore the idea of being the CS. Well, one of the CS meaning is computer science, but it's not here. Okay, the full form is code segment. Code segment. So here we are having the code segment that is used. Okay, I'm writing, just try to know its essence and then we are going to discuss it. So it's used for addressing. Just try to guess it by the name. The code is your hint. The code, the segment is just a segment, the piece. The piece is known as segment. So code is your hint and it is register, the address register. I'm repeating it again and again so that you can get your own way of coming to the conclusion. So addressing a memory location, obviously memory location in the code segment and let's say not and of the memory where the executable program is stored. Program is stored. Well, I'm done with my writing of the CS. Now we can discuss it. So I hope you have got through the idea of it. So let's just discuss and clarify that your learnings are correct. Okay, and if there's something to add, we are going to add that here. So CS means code segmented. What is the CS? CS is a part of the what? It is a part of the segment address register. Okay, so who is going to use the segment address register? Well, obviously microprocessor. Yes, you are right, but what specifically is going to use it? EU is going to use it because here what the real execution is going to happen, like here, this is the execution unit, but we are focusing on the BIU part right now. But you surely can see the arrow. I hope you can see this arrow. This is a two-way arrow, so surely it is demanding, so it is fetching the data. Okay, now as per our definition, the shorter definition of it, it is used for addressing the memory location in the code segment of the memory where executable program is stored. So you can imagine like we are having a memory, and in the memory what we are having is CS, SS, DS and ES. So now I'm not making the processor or address register, I'm giving you the data segment. So these are the data segment and this is our memory, like the RAM one, you remember, I'm sure. So this is the memory. So what the CS is going to get? Our CS, this is in the microprocessor. And what is this segment? Let me write it a little better. It will seem good, right? Sometimes I just try to write my words a little better. Segment register. So we are using the word register. It means simply the records of the address. That's it. So CS, SS, DS, and ES. Surely you might be not finding here that I am not writing the IP. We are going to discuss that, but for now we just require this much. So CS is demanding because the microprocessor is wanting it for the execution or for the fetching of the data. The CS is having the address, so it knows the address. Like imagine this is our CS and it knows the address. It knows the address of CS in the memory. So it is going here. They will both meet here and it will going to go here, take the data out, pick the data out actually, and then fetch it. So it will going to fetch the data for the next execution cycle. So this is what actually happening. So we are studying the BIU, sure, but the real game is on and all about the execution. So executable program stored data which is required is getting fetched by the CS segment register. I hope you have got the clear idea of what the CS is. Now let's proceed to the next one, which is our DS. Well, we can have SS first, whichever the choose you want to choose. It will not make much difference. We just want it in some order. That's it. So I'm writing it DS here. I like it that way. Okay, maybe I have written SS first, so let's do the SS first. So here is our SS, like here. Here is SS. Okay, let's meet the SS. What does actually mean? Okay, so again, let's start with the same way. I'm introducing you. SS means stack segment. Stack segment. So that's just the full form of the abbreviation SS. It handles memory yeah, to store data and address during execution. So that's it for the definition part. So what we have just learned here? Well, this is just the stacked one. So the data which is stacked means last in, first out, like the sack bags that you place one after another. So if you place 3 bags, so third one came the last, but when it's time to pick it up, this will going to be the first one. So this is also called as LIFO, last in, first out, and this is stack. Okay, this is the part of the computer science. Okay, now let's get back to this one. It handles memory to store data and address during execution. I'm again pointing the execution thing because ultimately everything is going to happen for the execution of the data. So what it is actually doing? It is handling the memory to store the data. So it is basically storing the data and address during the execution. So data and address is getting stored. That is the most important part that we have to stack up. Sometimes in our day-to-day life, we used to say that, oh, come on, let's stack it up. What does it mean? When you call it to me, I'm stacking. The stack of the books are there, like 1, 2, 3, 4. There are 4 books, or the stack of the files are there, like 1, 2, and so on. The nth file that we are having, imaginary one. So this is about the stacking. So what we are basically doing, we are just stacking the data. Don't go with this definition for just a moment. This is the technical part, that's it. I'm giving you the real glimpse of the SS. So the real glimpse of SS is telling us that it is stacking up, just collecting. So what it can collect? It can collect the data and the address. So it is handling the memory that is storing the data and addresses. Like I am storing a pattern of the books, like this is my math book, this is my English book, this is my computer book, this is my digital electronics book, and this is the sequence. So what I'm storing, I'm storing the sequence. And in this sequence, if I dig it inside, I can get the information that I want. So this is the data, and for that data I have kept the address to myself, like I have presented you here. SS is there, so SS will be called out and it will receive the data. So it is not keeping the data, but instead it is keeping the address. That is the most important thing. It is keeping the address, not the data. It is having the location of the data. The data is where? The data is always staying inside the memory. And where's the memory? That is the RAM, outside of the microprocessor. Yes, microprocessor is having its own memory too, that we are going to see, of course, but in this case we have to keep in mind that these two are separate entities. Like here, this is inside the microprocessor. Let's just write micro and P, and this is outside the microprocessor. This is outside MIUP. MIUP, microprocessor, processor, whichever way you would like to, you can call it. So this is the thing. Okay, I hope you have got the point of it. Now let's proceed to the next one. The next one in the row that we are having is DS. So you might already have guessed its full form, which is data segment. Data segment. So again, segment is the piece, data is the data, and what we have. So data segment, it consists of the data. Obviously it consists of data used by the program and is accessed in the data segment. Data segment. By an offset address. Well, we are going to see what are the offset address in just a while, because it's mainly the part of the execution. So we're going to see that. We will get back into this. Address or the content of other register or the register that holds the offset address. the offset address. So here we have it. Okay, we are done with the definition part. Okay, let me also tell you something that I really enjoy writing. Maybe you get a little bit of bored sometimes. You feel like, if you feel like even to this stage of reaching this course, I recommend. No, I am just saying that you will develop a lot of the patience because you are being with me, and this is what we are learning too. Keeping the patience, not in our speed. There is no problem with the speed. You can go very fast as much as you want. The thing is to stay in the moment. Your mind will work fast and sharp, I guarantee that. So let's begin. Okay, back to the course. Data segment. So, as the definition suggests, it is having something to do with the data. It consists of data. Well, that's simple. Not the data exactly, what it is. Data address, right? Used by the program, obviously execution unit is using everything. So data segment by an offset address. So offset address is actually telling us that which data has to be fetched and that is going to come, or the content of the other register that holds the offset address. Well, as you can see here, so here is our DS. So here is the data. Actually, the data is here, and here it's the register. It knows that where is the data. So what it has to do? It has to pick this data from here, and then it will fetch to the memory. Well, I'm using the word fetching again and again, so let me show you this one too, because ultimately this will going to give the input to ALU if there is some operation involved like plus, minus, multiply, divide, or whichever, and these are the operation units. We are going to discuss these one too, and then through the pipe of it. I hope you have seen my dots. So by these pipe, it is actually getting stored in the prefetched unit, like here or here, wherever you want. So it will going to get fetched up. It is not keeping it. It is just a medium where the address is stored, like the content of the book, and then it is getting stored in the prefetched queue. It is queued for the execution. Well, that's the whole story. Okay, I have yeah, I've got my idea about that. So it is not about the data, it is about the data register called by the offset address. We are going to discuss what is the offset address, so don't get worried about that. So this is the offset address that is going to come up, and then finally it will going to fetched and then queued and then go for the execution unit. Well, you might also wondering that you are seeing this. It is two-way. So what are these things? What are these things doing here? AX, BX, CX, DX, and all these kind of things. Well, we are going to discuss that. So be a little patient with me, and you will learn everything in just few of the videos, few of the coming videos. Maybe I guess two more videos, and then you will able to understand this entire concept like you have created it yourself. Okay, so now what we are left with in our row, that is the last one in the row, that is ES. So what is ES? Let's see. So E for the extra. This is extra segment. So whichever the extra thing you are having, you can have it here. So it is the additional data. Well, I am literally saying it. This is additional data. Segment, obviously. Additional data segment, because I'm using the word segment and being trying to be careful about these things because we are working inside the microprocessor. Everything is register or just the content of the book, the first page of the book, where you can have the location of or the address of where to go for the data. That's the whole concept of it. I hope you get my point already. Okay, so this is used by the string string, used by the string to hold extra destination data. Extra destination data. Well, someday if we meet, so we can discuss about our journeys if you love to travel. That way is the extra thing that is coming right here. Okay, so what does actually mean? It is the additional data. That is the keyword here. By the string to hold extra destination data. Well, I'm not mentioning the register thing again and again, but you surely know that these are the register having the content page, like content page. So what is the content page means? It is keeping the address, keeping the address. Okay, so we are actually and technically done with this part. I'm wrapping up this video for this one so that you will understand everything bit by bit and very clearly. Just to wrap it up, let's revise what we have learned. So we have gone through CS, DS, SS and ES. So what are they? They are segment register. So these are the register, just like the book, the content page that we have, where it is written that 1 to 2, 21 page number, the chapter number 1 is there, which is something, and similarly so on and on, where it is getting the data from the memory, actual physical memory. So it will going to be executed. Why it is calling the data from the memory? Well, because well, if you are using the math, you surely know that this is the symbol of because. I love to use this symbol. So because, well, it seems like mouth. Okay, because execution unit requires it. So technically what the BIU is doing is actually preparing everything what execution unit requires. So in the next one, we're going to see that what is execution unit, and I'm also going to tell you that what is the offset address. That technically is the part of this part, but I'm keeping it short and I'm going to tell you that in the next one. So till that time, keep smiling and see you in the next one.